All right, hi and welcome back. So we're going to talk about the next big thing. We're going to be doing an application of these definite integrals that we've been seeing. Now that we know how to calculate them, we can do all sorts of fun stuff with them. The first thing we're going to talk about is what's known as average value. We're going to calculate the average value of a function. Okay, so this is the definition for what the average value is. If we're looking at a function and we're looking at it only on an interval from a to b, the average value is simply the integral from a to b of that function. So in other words, sort of like the area under the curve in a way. But then we have to multiply by 1 over b minus a, or in other words, divide by the length of the interval. So graphically, what's kind of going on is the following. This is a, this is b, here's my function, this is the x-axis. Okay, so if I wanted to find the area under this curve, I would evaluate the integral from a to b, and that would give me exactly the area of this weird-looking region right here. If I wanted to find what the average value, in other words, the average y value of this function is, I could just take the area of this whole thing. If I divide that by the length of my base here, the length of the base is, of course, b minus a. That will tell me what my average y value is, right? Because my average y value, if I multiply that by b minus a, I would get the integral exactly. So this is a way of sort of calculating an average, which is something very useful in math to kind of know, what's going on in the long run, essentially. So if you have a function that's a constant function, of course the average is going to be that same constant. But if you have something that's going up and down, really undulating a lot, you might want to know, on average, where are we living? I'm thinking about like a tide, right? Like on average, what is the tide going to be in this location? Are we going to have very high waves, very low waves? Where are we on average? Okay, so let's just do some examples. Can you please find the average value of this function, f of x equals x squared minus 2, on the interval from 0 to 3? So this is one way to write an interval, right? This means that our interval is bracket 0, comma 3. So a is 0 and b is 3. I've got my function right here. And so if we just punch this right into the formula, we get something like 1 over b minus a, so 3 minus 0, times the integral from a to b, so the integral from 0 to 3, of f of x dx. And f of x is x squared minus 2. Okay? So basically all you're going to do here is we've got a definite integral right there that we know how to calculate. Let's do that real quick. Little f of x is x squared minus 2. That means that capital F of x is 1/3 x cubed minus 2x. Again, I don't need a plus c anymore because this is a definite integral. I can pick any antiderivative that I want. And then what I'm going to do is I'm going to plug 3 into this function, I'm going to plug 0 into this function, and subtract the results. Luckily, capital F of 0 is 0. Capital F of 3 is a little more complicated. It's something like 3, maybe? Is that right? 9 minus 6? Yeah, 3. Cool. So that definite integral is equal to 3. And the only thing that we're adding to this now is this coefficient, right? This 1 over b minus a in front. Here we're using b is 3 and a is 0. So I basically have to multiply by 1/3. What is 1/3 times 3, class? You are correct, it is 1. The average value of this function is 1, which means that from the interval, on the interval from 0 to 3, this function, x squared minus 2, is a parabola, right? It starts off at an x value, or at a y value of 0, and it ends at a y value of 7, right? Just plug in 0 and 3 to this function. But on average, or I guess the average value of the function, is that it's equal to 1. Okay. If you graph this in Desmos, I'm sure you can convince yourself that it looks like that appears to be the average value, 1. Okay, let's do one more example together real quick. This is another way of for me to write, the interval. I think we talked about this earlier in the year. This means x isn't this. Oops, why does this always do this to me? This part right here means x is an element of the interval 1, comma 4. Meaning that that's our interval. A is 1, and b is 4. Okay, so again, we're just using the formula. So you get 1 over b minus a, 4 minus 1. Oh, that also happens to be 1/3. It's not always going to be 1/3 for your coefficient. These two examples just happen to give you the same number. B and a could be much farther apart or much closer together than just 3 units. Anyways, then we integrate the function from 1 to 4, and the function is e to the root x over 2 root x. All right, so what is this going to be? Well, we get a 1/3 as our coefficient. That's the 1 over b minus a business. And then we've got this integral to calculate times something. Let's fill in the blank later. So we need to calculate the antiderivative of this function. That does not look like an easy one to me, but if you use u substitution, you'll get something real fancy here. Let u equal the square root of x, and then du is 1 over 2 root x dx. Oh, that's exactly what we have here. Perfect. So I think the antiderivative, capital F of x, is just going to be e to the root x. So we need to check. Typically we do plus c, but again, just take c to be 0. It's fine. All right, so all we're going to do is plug in 4, plug in 1, and subtract those two results. F of 4 is e squared. F of 1 is e. The difference is, of course, e squared minus e, which does not simplify. So my average value is 1/3 times e squared minus e. Okay? All right. Why are we doing this? We'll see in class, but this is kind of a cool thing to calculate. On average, on the interval from 1 to 4, this function takes on a y value of 1/3 times e squared minus e. That might have some useful implications for us. Okay, thanks for tuning in. I'll see you soon.